Here we are. Hey, good afternoon, Jan.
Good morning, Michael. How are you?
Doing well, very well. It's
Okay.
been
The snow
another
is
busy
gone.
week.
The snow is gone.
For the most part, yes. There's still a
Okay.
little bit sticking to the grass, but um, yeah, it should get sunny enough to melt that off before it starts to freeze again
Mm,
at the end of the week. So
okay. No, here it was quite cold, around freezing, but it was dry. But just now it starts raining, so
oh, hmm,
it's getting dangerous.
yes, that's a bad combination. Yeah.
Yeah, and early morning I have to drive 400 kilometers. So
Oh
I
wow.
hope I hope it's not gonna snow.
Yeah.
But okay, let's see how it goes.
Indeed. Yeah. Well, yeah. Did it made a little bit more progress toward being able to demonstrate a mesh of replicators all working together. So yeah, I think it's going to be pretty exciting.
Okay, okay, more exciting than my week. No, this week I've been looking into tunnels because for this old software,
Hmm.
uh, for one of the old softwares the problem is solved. I'm gonna rewrite it, but
Hmm.
the other one it's gonna be very difficult. So I'm gonna put a tunnel, a kind of inverse proxy server
Mm, yeah.
to adapt TLS 1.0 to TLS 1.3.
Mm,
And in meanwhile, customers want to have mails that are sent. There was already SPF for the sender verification, but
hmm.
now they want to have DKIM in place,
Mm.
which is signing of the mails.
Wow. Yeah.
But then, but it's very nice. Only
Yeah.
the mail, the SMTP provider, he cannot do it on
Mm.
that server.
Huh. So is that something that can be done with a reverse proxy then?
No, you have to. Well, normally you send a mail to an SMTP server,
Hmm.
and that SMTP server can sign the mail with a private key,
Hmm.
and upon reception, the receiver will automatically check it with a public key, which is stored in the as a record in the domain of the sender.
Yeah.
Yeah, so TXT record. Now Microsoft with Office 365 is doing it differently. They have forwarding, a CNAME which forwards you back to Microsoft, and so they keep the public key as well uh, safe for them.
Right.
Um,
Hmm.
which means that they can change both. They don't keep it safe for them. They store it so they can change it
Right.
if they
Okay.
want to rotate key pairs.
Yeah.
But so in this way, when you receive a mail, you can check whether the hash that has been calculated with the public key corresponds to the signing of the mail itself.
Hmm.
So you're sure that it's sent by that it is proved by the real domain and that it has not been tampered with.
That is awesome.
But but so if the SMTP server is not capable to do it,
Hmm.
I think you can just sign it yourself before you send it to the SMTP server.
Okay.
And
Yeah,
so
that would
that's
make
what I'm
sense.
that's what I'm looking into now.
Hmm.
Because in
Yeah.
fact you can just relay it from one SMTP server to the next one.
Right.
Um, so if I just install a small SMTP relay where I sign it,
Okay. Yeah,
but
that makes sense. But that does mean that the sender needs to have the private key that is normally associated with the domain. Um, so,
well,
so that's moving that
no,
one
no,
step further, I think. Or
you just generate. In my case, I generate a private and a public key.
hmm.
Private key I keep secret, and I use it to generate the signature which I attach to
Hmm.
the mail. And the public key I give to my customer in whose name I sent the mail,
Oh, okay.
and
Right.
so that public key he has to put it into his domain.
I see. I see.
So
Okay,
I'm
so
glad.
he's trusting you that you're going to take care of the private key.
Um, yeah, if I put the private key on internet, then it there is no use anymore.
Yeah.
But in that case, he can just remove the public key from his domain name,
Mm-hmm.
and whatever mail I sent from him in his on his behalf
Yeah.
will probably go in the spam.
Mm-hmm.
So of course I have to keep the private key safe,
Yeah.
and it's even not so difficult because there are very nice libraries to do that. But the problem is if you keep on adding computers, so I want to have that running on the old servers, but
Mm-hmm.
yeah, all this old stuff, new libraries on old operating systems.
Mm-hmm.
Um, you have to be creative sometimes.
Yeah. 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 So maybe somebody Edition Addict says hello. Hello, Edition Addict. Um, yeah. So maybe you look into containers so that you can run multiple containers. You put them onto one machine or virtual machine, and some of them can be old operating systems, and some can be. Although you're running on a Windows operating system, though, right?
Yeah,
Or,
and containers you can only go you can go back a little bit,
mm.
but with the old virtual machines it was a little bit better.
Oh yeah.
But uh, by getting older, it's not getting better.
Uh-huh.
Using old technology. But so one of the programs decided gonna rewrite completely um, because customers still want to add things, and
Yeah.
there's so much way to improve it and to make it more efficient. So I say, okay, let's do it. But okay,
Yep. Yep.
need another
Time to.
24 hours a day. But I'm curious about the mesh of replicators.
Yes. Yeah. Let's share that. So I will do the screen share on Zoom, and then just get that out of the way. Also bring that up in the stream. Okay. So in this Janaga replicator repository, I now have a mesh folder with this nice little Docker Compose. So yeah, Docker Compose is a pretty cool little tool that's just kind of part of the Docker ecosystem. It ships with any of your standard Docker runtime implementation. So I'm using Docker Desktop, as we've seen before. Got that running there. And with Docker Compose, you define several different containers that you want to run at the same time. So we've got a set of services and we've got a set of networks. Well, here we're just defining one network. It is the replicator network. And that's a bridge that connects all of these different services. So you can see these all participate in the replicator network. That way they can all talk to each other. So this one is actually both of them are based on the image Janaga replicator no security policies. So for right now with this demo, I'm using the version that doesn't have security policies configured. That is going to change as I evolve this demo. Now, I actually want to demonstrate security working in this thing.
Mm-hmm.
So we name each of the containers. This one's our front end. This one's our back end replicator. And then we map some ports. So internally, the replicator runs on 8080. So here I'll say externally, let's map this to 8080 and this one to 8081. That way from the host machine, I can talk to the front end or the back end. Over time, this is going to change as well, where I'll lock off the back end, and there will just be some back end processes, simulating some stuff going on in the back end. So that won't be exposed. You'll just be able to hit the front end, and then you'll see all the things happening behind the scenes. So we've got, for our backend replicator, I set the environment variable replicator upstream 1. So this is a new capability that I just added to the replicator, that the replicator Docker image, that you can set some environment variables. Oops. And tell it where to look for its upstream replicators. So in this case, just look for one, and it's the front end replicator. So that name has to match, and then it will basically, it's using that as DNS-ish. So it's just, let's look for that guy. Talk to port 8080. Here it's the internal port that it's concerned with, because this is all running inside the replicator network. And yeah, hit your Janaga endpoint.
The external port, because otherwise it would connect to itself.
Yeah. So this, first of all, it's naming the other container. So that's how it's not connecting to itself.
Okay.
Yeah, and then it's using the internal port because this is just how its port gets mapped to the host. But yeah, this is not using the host network at all.
I missed the front end replicator naming in the URL.
Yep, that's the magic that makes it all work. And then when you've got that, so I'm just going to change directory into the mesh folder, and then I'll do docker compose up. And that just runs docker compose, so it creates these containers, wires them up, gets them started, and you can see all of their code running. So yeah, there's the logo saying something started right. In fact, this is two logos layered into each other, because you can see front-end replicator and back-end replicator are both running. So they're both complaining that they have no security policies, and they're allowing anonymous access. And then they both say, yep, I am listening at 8080. Now, of course, localhost to them is the container. So that's why they both say 8080.
Yeah.
So now if I look back at Docker Desktop, I see that mesh is a collection of replicator or of containers. So we've got our back end and our front end, and there's our port mappings. And so I can dive into one, and I can see the logs just from that one. So now I can see the logs all nice. Okay. So with them connected like this, where the upstream of the backend replicator is the front-end replicator, that means that everything that I send to the backstream is going, or the back end is going to be immediately published to the front end. So, yeah, everything flows upstream. Rivers are weird, just like arrows point up. Yeah, rivers flow upstream. It's a crazy upside down world. So to demonstrate that, we've got this HTTP folder. I've got some. Let me just get down to these so I can take a look at everything. So we've got our write test that creates a blog site, and our read test that reads a blog site. And the last time we looked at these, we were talking about authorization. So we've got the authorization code stuff in there. And if I look at environment local, then that's got the Fusion auth stuff configured that we did on stream. So let me create a couple of other environments. So I'm going to have env. This will be backend. And so for this one, I'll use the replicator URL. This will be HTTP. Localhost 8081 will be the backend, and the Janaga endpoint there. And so what I should be able to do, since information is flowing upstream from the backend to the front end, if I create a site and I don't use authorization because I've got that all turned off, I should be able to post this to the backend and see it flow upstream. So we're going to call write. Now here, since I've turned off authentication, then I don't have the me fact anymore. I'm not a logged in user. So I'll just go ahead and create a fake public key. And then I'll be able to create that because there's no authorization. So when I run that, bloom, I get created, and then I should be able to look at the, let's start with the backend, and in here I should see that, oh, okay, I need to update my my images. The images now contain better logging. So this isn't telling me much. It just tells me that I've connected to the database. But now there should be logging that tells me that I've written some facts. So let me go ahead and update my containers so that we can, or my images, so that we can see this a little bit better. So this is still running here. I'll hit Control C, and that stops the the whole set of containers. So stopping both front end and back end. You can see these shutting down, but the whole collection there, which is called mesh because that's the name of the folder that I started it in, that collection is still around. So I can do a docker compose down, and that deletes the collection. Now I want to get fresh copies of these images, so I do a docker compose pull, and that does a pull on any image that's referenced in that docker compose file. So you can see that they both reference the same image, so it just pulls it once. And now if I do a docker compose up and repeat this this whole process, I should see something a little bit better. All right, so they're running. Here's the back end. Here are the logs. And then I create that fact. And now, there we go. So I've got a counter that that counts the number of facts that were saved. So we can see the facts saved counter was incremented by 2. So I just saved 2 facts, the creator and the site. And by the way, a little little teaser for what's going to be coming up in a couple of weeks is I'm working on an open telemetry endpoint for these counters. So excuse me. Prometheus, I think, is is the front end that I'm going to choose, and that will be part of this Docker Compose. So it'll be all wired up with OpenTelemetry, and you'll be able to see all these facts flowing through the system by looking at Prometheus. So that's going to be cool.
You can have a dashboard where you see everything.
Yep. Okay. So now we've got our facts saved, and so now if I wired things up correctly, because I saved them to the back end, if I go to the front end, I should see that there were 2 facts saved there. But I'm not seeing it. Oh, wait, yeah, here it is. Fact save incremented by 2. Yeah, not sure why we had these Postgres logs after that. But, okay. But yeah, so we were able to save some facts to the front end because we had that connection flowing upstream. So that means I should be able to create one of these environments. So now we're going to have a .env for the front end.
And read the facts back from the front end.
Yes, exactly.
Mm-hmm.
So that's going to be 8080. And now if I do a get sites, no authorization, and choose the front end environment. Boom. Oh, the fact me is not defined? Of course not. Let's go back here. Use this same user. There we go. Now I get the qedcode.com site that was created. Mm-hmm. And I can see here, facts read 1. It only had to read 1 fact because I supplied the creator. It's like, okay, you already know about that one. So I'm just going to read the excuse me, the one that you don't know about. So that is the first little bit of the demo.
Mm-hmm. That's nice. Now we really see them communicating.
Yes, indeed. Yep, and that all goes through. If I look at backend and I inspect, I can see the replicator upstream 1. That's what makes it all happen. So yeah, the plan is to support multiple upstreams. Right now, it only supports 1 upstream, but yeah, go ahead and fan out to all of the upstreams. And the next thing that I am currently working on is to have, in addition to our subscription files or our policy files, to have subscription files. So we talked about policy files. Like here's one that defines our authorization rules, our distribution rules, and our purge conditions. Mm-hmm. And so the plan is to have subscription as another one of these groups, and then you'll be able to have your specification inside of subscription. And in addition to the specification, you will have your you will be able to declare some starting point facts. So it basically looks like this much of the read. It doesn't bother with the projection. No reason to project them. Yeah, if you want to have a projection that then goes to some child subscription or child specifications, that we find they'll all get added to the subscription. But yeah, it's going to basically start a connection with all of its upstreams, and say I'm going to subscribe starting at this fact to everything that matches this specification, and that's how you'll pull information from the front end back down to the back end.
So that subscribe query will be on the front end in this case then.
In this case, it'll actually be on the back end. So since the back end is pointing at the front end, in fact, it's probably easiest to point here. Yeah, since the back end is pointed to the front end, then the back end knows about the front end, but the front end doesn't know about the back end. It's just, sitting there doing its replicator thing. So if somebody calls in and says, hey, I'm interested in any of these facts, then it'll say, okay, I'll keep that connection open, and anytime I hear something, I'm going to send it down that connection. So yeah, it's the back end that needs to give the front end the subscription. So the file will actually be mounted into the back end replicator.
Okay. But for the moment, it's so that all the information that gets into the back end automatically goes to the front end.
Yes, and that will continue to be the case. So yeah, whenever a replicator receives information, it sends it upstream. And then when it wants information, it subscribes upstream. So
Okay.
it says, this is the set of information that I want. So that's kind of analogous to a client application. So you're saving facts in the client. They're just all going to flow upstream. They're all going to flow to your central replicator. But then when you open a page, you look at at some results, it's going to run that specification and pull those results back, so that you can see it.
In this case, the front end is in fact the central replicator.
Yes.
Okay.
Yes. Yeah, as I expand this out, what I'm expecting is that there will be a front-end replicator, there will be a central replicator, and then there will be a back-end replicator. So even the front end is going to push its stuff more centrally. And so that way we can have all of the security, all of the authentication rules about who can log in from a mobile device. That's going to be on the front end replicator, and then that central replicator is going to be kind of the hub, and there will be different kinds of back-end replicators. So based on what those back-end services are intending to do. Yeah, and it looks like we got signed out of YouTube again. So I'm going to get signed in just in case our friend Edition Addict is trying to talk to us. Okay. Yeah. I really wish that the timeout for those was not at a week boundary. So, yeah, that just basically means that it's going to require me to sign in every day, every stream. Okay, I think we are good. Almost. I can't quite see the chat. It says something went wrong with the chat. Okay. Well, hopefully that will come back and we'll be able to talk with our friends. So, yeah, so that's going to be the subscriptions. Oh, yes, I did want to show where we're going with all of this. So I'm going to...
Michael,
Go ahead.
But so if you want to have a server as a kind of backup, a replicated instance of the database, then we can just connect another front-end server to the central server.
Yes. Yeah. So, in fact, in which chapter was this? This was chapter. I thought it was earlier than. Oh, generated behaviors. Goodness, this is the first edition. Let's see. Check out second edition. This is not the. This is not the right one. All right. LGA. What are we looking at? Man. All right. I must have 2 copies of this repository on my machine. But yeah, this was 4 years and 6 months ago when I finished writing the first edition of the book. So now if I get check out second edition. There we go. Now we've got the new chapter structure. So immutable runtimes, chapter 6. If we go here, I want to talk about replicators. So we've got different diagrams in here representing the evolution of a school system, or a school IT system. So this is basically the structure that I want to create. So what we're seeing so far is a single front-end replicator and a single back-end replicator. And I've got the back-end replicator, its arrow is just pointing straight to the front-end replicator. But what we ultimately want this to be is this is the replicator that all of these front-end applications are using. In this case, we're modeling a web application that uses server-side rendering. So each of these different web servers has its own replica. And yeah, let's see. I'm concerned that the stream might not be live anymore. Yeah, it does say it's live. Yeah,
YouTube.
So, yeah, YouTube is acting really funny. Okay, well, I can see us moving on the screen. So yeah, each one of these web servers has its own replica, and they are collaborating through this student replicator. So using that replica, they're able to serve web requests, generate HTML responses, send them back. So this is not the single page application type of framework. It's just these are just each of the different web services basically acting like a client. And then and so this one student replicator can handle that number of requests. It's not really going to need much redundancy. And then it flows uphill, and so yeah, we've got these lines indicating different levels. It's supposed to be like topology. You're looking top down at the top of a hill. So at the top of the hill, you've got the hub, which is a cluster of replicators. And so these will all be configured to connect with one another. And so no matter which one you connect to, you're going to be able to see what happens on all the others. It's sort of like a Kafka cluster of brokers.
Okay, so if one of them fails, the others will just continue.
Yep, exactly.
Okay.
So then this course catalog, the idea here is that we are we've got some legacy connection with with partners. So we've got a group that is producing curriculum for us. Then we've got this FTP folder that we use to share those curriculum files. So this integration here helps us to basically turn those files into facts. And so it's got its own little replica, and it's using this course catalog replicator as its upstream. So with this, everything's flowing uphill to the hub. And now in order to get the information that you need, you just pull things downhill through subscriptions. So for the student replicator, the subscriptions are all about showing course information to the students, and then also a subscription to pull down all of the registration information. Excuse me, so they can see what courses they've registered for. So that's the only information it's interested in, so it expresses those as subscriptions. And then when these are running, they're going to be running those queries, so they're going to be pulling that information from the student replicator and caching them locally and then serving up those web pages. So yeah, I want to build out a Docker Compose that is basically all of this. So we'll have some simulation of this this Lambda running in the back end over here. We'll have some simulation. I might actually even use Elasticsearch to have this index that's pulling course catalog information and then updating an Elasticsearch index. And so then this is made available to these web applications so that the students can run a search, and then it'll do the Elasticsearch query and pull that information back. So that is the scenario that I am trying to replicate. Pun intended. All right. Trying one more time to log back in. See if
it's still live. It's still live on YouTube.
Okay,
it says streaming started 37 minutes ago, so it looks like it never got interrupted.
Okay, good. Yeah, and if somebody is trying to chat with us, I'm not seeing the chat, so... Okay, there we go. Now I've got the chat back. And nope, we didn't miss any messages. Okay. Very good. So yeah, that is what we're working toward. Now there is something else interesting here to that I want to show in the simulation, is that so the student replicator subscribes to the hub, and so the hub has to know that the student replicator is allowed to do so. So so while the student replicator has a subscription file, the hub replicator will have a policy file where the come back to my policy file here. The distribution rule is set to distribute that information to whoever asks. Well, not whoever asks, but it's going to share that with certain identities. So we basically want the distribution rule to mirror the subscription rule on the other side and say, yes, you are allowed to pull that information. So far, the distribution rules are all about actual users within the model. So we can share, in this example, all of the sites with the creator of those sites. So that means the site's creator themselves, a human, can pull that information from the replicator. But in this case, we've got replicators talking to other replicators. So that means the distribution rule is going to have to be expressed in a way that it's not a user, but in fact it's a replicator. And what does that actually mean? So for that, I'm going to go to some of these security ideas that are in Chapter 9. And, well, actually, there's an application pattern. So in Chapter 7, we've got application patterns like enterprise. And, yeah, here's the dot for that. I think, yeah, I think I have to compile and run everything in order to see this. We might be able to get that working, but yeah, here's a little hack. If I instead use graph viz, and then I say I want to preview the markdown. Open preview. Bloop. There we go. Yeah, now it renders it, but it doesn't recognize dot. It recognizes graph is. So we've got that. Get that. Let's look at this graph is. Yeah. So now we should be able to see both of them in the preview. There we go. Okay. So with this pattern, so this is the enterprise pattern, enterprise domain pattern as described in the book. And so with this pattern, I'm not rendering it properly, but we've got a there we go. We've got a user with their public key. This is a single-use key, so we create this user on the fly, and then create our environment with that user. So they're the only user that's allowed to create that environment. And then that user is allowed to invite administrators to that environment. And those administrators are users with their own public key. So these are actual people that work at the university in this case that are setting up the IT system. And this is a one-time key. It's created on the fly. You invite your first administrator, and then that private key is destroyed. And so now you've got an ID that represents represents something that that happened once, and then you've got administrators that can grant administrator privileges to other administrators, and now you've got the people, and none of these are in a privileged position, so none of these are the actual creator of the environment, which means that once that first administrator leaves your organization, you can revoke their privileges, and there's if we had a real person creating this environment, you couldn't revoke their privileges. They're connected to that environment immutably. So starting with this pattern, and you can see here's an example of this pattern where the administrator creates the environment. We've got work happening in the environment. In this case, we've got a catalog of products. But then this administrator invites another administrator. In this case, this same administrator creates a different environment. So now we've got our test environment and our production environment. But using the same kind of pattern, we can create public keys that are used by machines and not by humans. And so I did something like that in the replicators as a service. So let's see if I can find that. So this is going to be app.janaga.com. I think that's the one that I want. And so yeah, here is the the notebook describing how all of that works. So let's go ahead and run that notebook. It's bringing in the model. We can see the model notebook running up there. And then here it's describing how things connect with the Azure Marketplace, that sort of thing. So here we see that same pattern. So we've got our Janaga user, that's the replicator or the creator of the environment. And so that was a one-time use. And then there was an administrator that was created at the same time. But you don't see the administrator in this flow because we are focused on the service principal. So the replicator also creates service principals. So we've got a Janaga device, which I think I'm actually going to get rid of Janaga device. The distinction between device and user as different types, not very helpful. So this will probably just become Janaga user. And you just know I'm using this Janaga user as a service principal. It's not a person who logs in. But yeah, so this service principal is actually a machine that has the private key and can prove to other machines that it represents this Janaga user. So I'm using this in order to, do I still have the diagram open? I don't. But I'm using that in order to demonstrate that the Lambda, that backend service that is connecting to Azure and running the Azure API, that it is allowed to do certain things. So I've got distribution rules in here that are specific to this service principal. And it says, okay, if you're a service principal for this Azure environment, then you can get this information and you're allowed to create that information. But that's just around what the API can do. So yeah, in this case, you can get requests for an endpoint. And then you can create that endpoint. And then you're using the Azure API in order to set up API management and create that endpoint. So so that's the sort of thing that will be put into those distribution rules in the throughout the model, but especially in the hub. And so you basically make each of the different replicators service principals themselves. And then you decide what the security rules should be for different kinds of service principals. And that allows you to control the flow of information through your mesh.
But then, if that replicator is managed by an external party, you have to be sure that it's that replicator and not another one.
Yes.
So there you enter the world of certificates.
Yes. Yes, indeed. Yeah, I am. I'm thinking about how do certificates map to the model. Right now, the model is just public keys. So so I'm just at some point an administrator says this particular public key is a service principal. But with certificates, you've got the chain of trust. So I could have it look not just at the public key, but also at the chain of trust in that certificate. Say, okay, well, this is signed by somebody that I trust, and so then it's implicitly got this service principal oh goodness, it's playing that role. And so I'm trying to figure out should it um, should it create facts when it sees a chain of trust? Should that be something that the library itself does? Um, should that be something that I expect your code to do, or maybe something in between, where I can ship um, a component that does that, and you just have to enable that component and configure it with your root certificates. So yeah, not really sure where that should be. Or the alternative is that it doesn't explicitly create these facts, but somehow the library is able to imply their existence just based on chain of trust. And will those implicit facts still work with all the other rules of how replication works? So yeah, bunch of things to think through.
Because you could also just distribute, hand over a key to the third party.
Yeah.
Then you don't need the chain of trust.
Yeah, yeah. For the third party, this actually kind of goes back to the email conversation. For the third party um, to be able to sign, it would need to have the private key. And so rather than you creating a key and then giving the private key to the third party, have them create the key, and then the standard way of them sharing their public key with you is through a certificate signing request. So we're back to that, and then you can sign their certificate and give that back to them. But you could use a non-standard way of just, okay, I've created this key pair. Here's my public key. But the CSR is safer. It's got more steps in the protocol so that you know that somebody didn't intercept the public key and replace it with their own. Yeah.
Posting USB keys with a public key on it.
Yeah. Here you go.
Private key.
Yeah, you're safe now. Just plug this in. Yeah. Yeah, so that's what we're working up toward. Making incremental steps to get there. And to kind of go along with it, I'm posting a series on LinkedIn that's intended to demonstrate the power of replication over the traditional methods that we are using. And when I say traditional, I'm including modern methods. So the idea of setting up an event-based distributed system. So you're setting up queues and topics and and you're doing all this this configuration versus here's the model and here's the topology, and now where the model intersects the topology, we've got these files, just policies and subscriptions. So there does have to be somebody who understands both sides, but that's a very small intersection versus, hey, I just have to set everything up.
Oh, it's nice to see that mesh demo where just containers and then they talk automatically to each other.
Yep. I want to. Once I've got it even more exciting than that, I want to take that on the road and say, okay, spin this up, boom, and now let's go into Prometheus and let's see all these things working. Even have some automated client simulators. So it's like, okay, let's go ahead and turn those on, and then things are just flowing. So you're actually seeing seeing how it responds under a load. It's all running on one machine. And maybe even spin it up in the cloud. Okay, this is what it would behave like in a real environment.
And why this Prometheus? Why the choice for Prometheus?
Yeah, there are a few options for OpenTelemetry. Prometheus is an
Mm.
open source visualizer that has some pretty nice dashboards. So I think it would make a good visual demo.
Yeah.
But yeah, just using that tells the story that no matter what you are using for observability, yeah, this is OpenTelemetry. You just plug in. You can see right here how the plugin works. Yeah, I'm shipping the demo, so yeah, you can set up your own observability for your own system. So if you're like at my current client, we're using Datadog. So yeah, you plug Datadog into any OpenTelemetry application, and it lights up.
Yeah, that it's a standard interface for
Mm-hmm.
this telemetry.
Yes.
Okay,
Yes.
so
Yes.
they can use whatever application they like.
Yep. Yeah, OpenTelemetry is a fairly recent standard. Yeah, prior to this, it was all like the Elk stack was probably the most popular thing before OpenTelemetry, um, where you have to configure things that will read from a log file and then turn those into messages that go
Mm.
into, in the case of Elk stack, Elasticsearch. And then you've got a front end that reads from Elasticsearch and searches for logs and aggregates things and builds dashboards. And that was Kibana in that case. But yeah, with OpenTelemetry, it's like, okay, these pieces aren't all designed to work together. Instead, they're all designed to work with a standard, so they do
Mm.
work together.
Okay, so that can be used for a lot of things like hardware, server monitoring.
Mm-hmm. Yes, indeed. Yeah, in fact, yeah, out of the box,
Yeah.
that's pretty much what you get for free. Is that okay? It's going to show you CPU memory utilization
Mm.
for all your servers. It's just boom, there it is. Um, you want to do something else, then you can plug OpenTelemetry libraries into a lot of application runtimes like Node or .NET or
Mm.
Java Spring, and then it will just uh, give you the raw telemetry for just the runtime. It's like, yeah, okay, I called this function and threw an exception and that kind of thing, or even down to like if it's ASP.NET or Express, any of these web runtimes. I said, okay, I can hook into the requests, so I can show you the number of requests and
Mm.
filter them by path and by the verb and all that stuff. But then if you want to actually instrument your code, then you can add counters and metrics and logs to your code that then are visible through OpenTelemetry. You can get pretty detailed.
And goes that even further to hardware, where you can see, for example, in a network, these servers are up. Uh,
Mm-hmm.
if I send, for example, a simple ping
Yes.
every 2 minutes, um, does that make part of that standard, or?
I believe it is. I know that it's part of Kubernetes, that it's going to use those pings in order
Mm.
to recycle the pods. It's like, oh, it's not responding. Let me go ahead and
Yeah, a
so
watchdog.
yeah. So which reminds me, I do need to add that to the backlog. I need a replicator to have a uh, a liveness check endpoint, so
Mm.
that we can just run it in Kubernetes and it'll do the right thing. Um, so, but yeah, I think OpenTelemetry. Yeah, the reason that I'm not certain about that is that when that happens, basically the telemetry stops. So it's looking for a negative signal. So it might not be part of the OpenTelemetry standard, but it might be part of the dashboard, where it's like the
Mm.
dashboard knows which servers to look for, and then observes that negative signal. There are things like Argo. Argo is a dashboard and a runtime for Kubernetes. So so it knows what the Kubernetes cluster should look like. I think it does that through Helm. And so it's got that extra information, and it can see there's supposed to be a a pod here, and it's not healthy, so I'm going to show a red indicator. And so you can just see a dashboard of what's down, what's up. You can just glance at that, say, okay, go ahead and restart that pod.
Okay, that might be something interesting also.
Yeah. Yeah.
I'm gonna look into that.
Yeah, this is getting into a whole new world of DevOps.
No, but monitoring systems, it's always nice if you can call a customer and say, it's going to be up again in 1 hour.
Yeah.
Then that he has to call you and say, there's something down. Oh, is it?
Yeah.
So,
yeah, and you should be able to take this all the way to the point where you've got a public/status page on your site, and even without authentication, people can just log in there. What's the status? Like if you go to Azure, Azure.com/status. There's a status page. You're not even logged into Azure. You're just seeing there's the status of the world.
yeah, if you drive that further to politics, then you can see, okay, the Russians, their missiles are standby. The Americans.
Yeah, I think that's called ground news.
Not everything has to be public. I think it's better that way.
Yeah. Yeah, but yeah, you get to choose what you're going to make public. That way you can your clients can self-service. It's like, oh, I see that there's a problem with the with the service, and there's a mitigation note on there. It's like, okay, we're looking into this. It's going to take this long. That way, you can avoid some of those phone calls. You'll still get the phone call even if there's a message there. Say, hey, it says it's going to be up in 10 minutes. Is that true? And say, well, now I've stopped typing in order to answer the phone, so now it's going to be 12 minutes. Okay.
Good. No, there is some nice evolution there.
Yeah. Yeah, it's fun. All right. So yeah, next week we should see subscriptions working. Yeah. See how much further we get.
Okay, then go back to work. See you next week, Michael.
Indeed. See you then, Jan.
Bye-bye.
Bye.